All right, last but not least, we've got lines of symmetry. All right, line symmetry, what it's actually asking is there a line I can draw to where if I fold along that line, essentially the two sides will fold on top of themselves. All right, where you won't be able to tell where one side kind of peeks over the other. Well, right here, this first object, it actually has 4 lines of symmetry. Okay, if I put this a line up the middle, if I fold this half onto this half, you would not be able to distinguish the two from each other. Also, if I do it from this half to this half, right here would be a second one, or somewhere around there. If I fold this half to this half, it would work. Diagonals would also work. Alright, this may not be the most perfect square. I'm meant to try my best, but so this thing right here has 4 lines of reflection. Alright, so it's got 1, 2, 3, 4 lines of reflection, meaning if I fold across any 4 of these objects, it will essentially fold paper in half, and the 2 halves will fold on top of each other. This arrow. Well, this arrow, you can't fold it right here because this half wouldn't match that half. You couldn't fold it right here because that half wouldn't match that half. There's only one actual spot, and that is up and down. If I fold this arrow from top to bottom, it's the only spot where I could fold it, and it would actually fold in half. Now, the star. What a lot of people like to do is they see, oh, well, I've got a line of reflection right here, and then they stop. Well, it's not your only line of reflection. If I just turn the page, it looks like the original object. So I can once again draw a line of reflection right here. Turn the page, draw one right here. Turn the page, I can fold one right here. Once again, turn the page again, and get one right there. So technically I have 1, 2, 3, 4, 5. I have 5 lines of reflections on this star. That's how you find the number of reflections. Now, determine the rotation of symmetry. Okay, so rotation of symmetry means that I can rotate this object. Okay, so like if you've seen it on camera, if I rotated this object, it looks like it did when it was in its original position, like right here. Okay, if I just turn it like that, it looks like like I didn't change the orientation whatsoever. Alright, that's what's known as rotational symmetry. So what you have to look at is, does it look like it's uniform all the way around, meaning all these little peaks right here look about the same size, alright? Now, if they do, this is what we do to find the rotation of symmetry. We count the number of points. 1, 2, 3, 4, 5, and 6. Okay, so we have 6 points right here. Alright, we're going to use the number 360 because that's what we're always going to be using, is 360, okay? And we're going to divide by how many points we have, which is 6. When we do that, we get 60 degrees. So that means that this object right here has a 60-degree rotation. So if I move this point 60 degrees to right here, it would look like it didn't even move at all. It's a triangle. Well, it looks like all the sides are uniform, meaning the same length, same size. Let's count the points. 1, 2, 3. There's 3 points. So we're going to take 360, we're going to divide by 3, we'll get 120 degrees. So the answer there is 120 degrees. Now this next one, alright, it's not like these two where it's like uniform all the way around. Right here, it's at that point where it's not really the same size, alright? Alright, it doesn't look like I could rotate it 20 degrees and it would be the same. If you look at this right here, if I rotate it just 90 degrees, it's going to be pointing up like this. Okay, it's going to look something like this. Okay, so that's obviously, you can tell that that's not going to be in the same spot it originally was. So, If an object doesn't look like one of these first two, then we can ask ourselves, the only rotation this can have is a 180-degree rotation, meaning if I take this point and I move it to here, and this point moves back over here, will it look like it was in its original position? Well, for this object, yes it would. So we can say that this only has a 180-degree rotation. So we don't have to do this whole 360 thing. We only do the 180 when it looks like the object can only rotate once, and it has to rotate essentially 180 degrees for it to even work. Next part. It says determine if the following has rotational, reflection, symmetry, both or neither. Well, this first one. It looks like it has reflection symmetry because I could draw a line right down this middle. Alright, and it creates two equal halves. So it has reflection. But I can't rotate this. If I rotated this 180 degrees, it would look like this. Okay, it would be in this position, which doesn't look like, it's not in the same position this was. So this is not the same, so it would not have rotational. So all this one has is reflection symmetry. Well, let's look at this one. This one has at least one line of reflection. So we know it has one line of reflection. And it looks about uniform all the way around, so I would say yes, this also has rotational symmetry, meaning I can move this, turn it, and get it to look like it's in the same position if I just turned it once. So it has reflection, it has rotation, so it's got to be both. This heart. Well, can only divide this heart in half. Can't rotate it, so all I have is reflection. So this would be reflection. This one. Alright, I can't really draw a line of reflection right here because that doesn't match that side. If I draw a line right here, once again, it's not going to fold on top of itself. So this thing does not have a line of does not have a line of reflection, meaning it doesn't have a reflection symmetry. But it does have rotational symmetry. So if I took this object and I moved it 180 degrees and took this object, moved it here, took this object, moved it here, it would look like it's in the same position. So this actually has rotational symmetry. Finally, this last one, can't really divide this in half, and I can't really rotate it. So this really has neither. Alright, so this would be neither. Alright, so that is the review. The test will be on Tuesday, considering it's a snow day. So if you have any questions, please ask from now until Tuesday. Thank you for listening.